Hi everyone, welcome to Access Prescripta. In this video, I am going to explain osteo and arthrokinematics, how these two things works together, and most importantly, we are going to discuss about the concave convex rule. Just entering into the concave convex rule, we have to understand what is the difference between kinetics and kinematics. Very simply, because why we are calling this an arthrokinematics and osteokinematics. The kinematics, why we are not calling as kinetics? Because simple logical point, kinetics that we can't see, kinematics the movement we can see. So this is calling kinematics instead of kinetics. So what is osteokinematics? Basically, osteokinematics is simple. When the muscle pulls the bone is moved from one direction to another direction. Maybe there is a flexion, abduction, extension, internal rotation, external rotation, adduction, whatever. That is called as a osteokinematics. Osteo means bone is moving here. When it comes to arthrokinematics, as I said before, one muscle is pulling the bone is creating the movement, bone is attached to the another bone by forming the joint that is considered to be an axis. That two bones are moving each other, then inside the joint there is a movement happening, roll, glide, slide, that is considered to be a arthrokinematics. Because arthro means joint, kinematics means movement. The movement happening inside the joint, that is called arthrokinematics. Now let's see what concave convex rule teach us. How these osteo and arthrokinematics movements are happening together. Almost every synovial joint except the plain variety of synovial joint, every joint has both concave and convex surface. Consider I am taking example of knee joint. The tibia articulation is concave, femur articulation is convex. Okay. When the person is extending the knee, concave move against convex. Concave move against convex. See, simple knee extension exercise. So here osteokinematics are extending the knee. So you can see here, glide also happening in the same direction. Okay, the tibia face glide over the femur condyle, but both happening in the same direction. Glide also happening in anteriorly, movement also happening front. So both in the same direction. When the convex surface moving and concave surface, both in the same direction. Now consider the person is doing squat, like this feet is attached here, and the person is doing squat. Now the person is flexing the knee. Femur osteokinematically going to the flexion, downward direction, and you can see here convex move again concave surface. When the flexion is happening, movement happening in that direction, but the glide happening in a anterior direction, front direction. That is a different direction, this is a different direction. When convex surface move again concave surface, both movement happening in a opposite direction, not the same direction. Let's take an example of shoulder joint. Head of humerus, convex surface moving in concave glenoid cavity. When I am abducting the shoulder joint, the osteokinematic movement happening in upward direction and glide was happening in a downward direction. The most important thing most of us doesn't explain, you have to understand here is the direction of arthrokinematics, the same direction, ligaments and capsules will be in a tensed position, and opposite direction ligaments and capsules will be in a relaxed position. Like when I abduct, inferior capsule get lengthened, inferior glenohumeral ligament will get lengthened. Okay, the same thing applies to here also. When I extend, roll will happen anteriorly, then anterior glenohumeral ligament, anterior capsule will get lengthened, posterior will get shortened. The same thing applies to hip and everywhere. So now I will give you one work. Consider the person doing standing calf raises. What it will be the osteokinematics and arthrokinematics of the ankle joint. Which ligament will be in a taut position, which ligament will be a relaxed position. Type your answers in the comment section. See you in the next video. Happy learning.